Hi, so I'm Dylan Clements, and I'm joined by Timothy Howe, Jake Lauer, and Connor Tim, and we're working with the company on their 5-axis CNC router as part of a senior design project for the Iowa State University Industrial and Manufacturing Systems Engineering Department. All right, so our problem is that our company would like more financial justification for using their CNC trimming cell more, as it is much faster and safer than trimming by hand. However, they currently program the machine online and are looking for a way to program offline from the CAD models that they already have. Our objectives for the project are to evaluate some of the offline CAM solutions, evaluate other avenues for offline programming, assess and recommend a short-term solution and a long-term solution, and evaluate any changeover related to the CNC cell itself.
To compare the two processes, we'll look at the safety and quality of both issues. In the short term, hand trimming poses some safety concerns through cuts and lacerations to the operators, and in the long term through cumulative trauma disorder, which is essentially the repetitive movement over time causing injury to the operators, and we found significant evidence of this with workers at the company. Additionally, parts are scrapped at a much higher rate from the hand trimming process than compared to the CNC process. We received access to hand trimming data for cycle times for parts ran on the hand trimming process, and we were able to simulate in Mastercam how long it would take to trim parts on the CNC machine. And also we were able to compare some of this to industry references, and what we found was a 40 to 90% reduction in cycle times based on the size and complexity of the parts. Running parts through the CNC machine is faster every time and just a much more efficient process.
Currently at our company, there is no offline program being used, which means that all tool paths must be programmed online. Currently, all the parts are designed using Siemens NX. However, we discovered that the parts can be programmed using Mastercam for the tool paths. Time per part is approximately 30 minutes to 2.5 hours for an unexperienced operator using Mastercam. And some of the challenges we're having to convert from a 2 to 3 axis milling to a 5-axis milling. And rooms for improvement would include creating a post processor for the code that was generated via Mastercam in order for the Fagor system to understand it.
As far as offline programming is concerned, both Siemens NX and Mastercam offer introductory courses. However, Mastercam has a lot more third-party training available, but both programs are very similar in pricing and feature set, so the distinction here should be down to the company or corporate preference.
To assess the effectiveness of the changeover, what we did was we created a setup baseline worksheet. This would break the changeover process down into each individual action that the operator took during the changeover process, and it would help us identify the internal and external activities. Internal being activities that must be done while the machine is not operating, and external being activities that can be done while the machine is running. The biggest source of external time that we found in the changeover process was in putting away and retrieving new and old fixtures. A couple of solutions that we had to this problem was to either relocate fixtures while the machine was running, which is ideal but is only possible when the parts being cut have long cycle times, borrow an operator from a neighboring hand trimming cell, which would enable us to do it with shorter cycle times, but we would lose hand trimming time in that process, and more research would have to be done to see if that was optimal. The other idea would be to stage the fixtures, every fixture that you were going to be cutting at the beginning of the day, and to put them all away at the end of the day. This could be done with a single operator, but cutting time would be lost at the beginning and end of the day.
The project has a variety of economic impacts for our client company. First, we believe that we can reduce the changeover period by approximately 50%, which would help increase the throughput of the machine, which is one of our objectives. Additionally, with the current inefficient method of programming, it's taking about 312 hours of offline labor, and this is on overtime pay. Reducing that would significantly cut their labor costs. Additionally, increasing the throughput of the machine would lower costs for the whole facility as a whole, with the overtime labor cost going into that and the longer cycle times for parts that were hand trimmed versus CNC trimmed. Additionally, we found that CNC is a significantly safer process, and the risks of injury to the operator is significantly lower when we decrease the amount of product being ran through the hand trimming processes. Additionally, is significantly better cycle times for parts ran through the CNC process. We discovered up to a 90% reduction cycle time through parts with Winnebago and also parts in industry references.
So we started out by discussing CNC versus hand trimming, and we recommend a move to hand trimming based on the economic opportunities previously discussed. Operators are at a lower risk for acute compounding injuries, and the economic and quality improvement is substantial, which is represented by a large decrease in scrap parts, along with a 40 to 90% decrease in cycle time. This is all facilitated by the inclusion of offline programming. Our short-term recommendation here is to outsource the programming with a firm that's more familiar with it. Once the gains from this are realized and a justification can be made, they should switch to an in-house programmer.